remembered we had it at 11:30 today, but I was in the middle of something, so just got out of it.
Okay. Are you able to see my screen?
Yeah.
Okay. So, the last class, we discussed up to data warehousing concepts, right?
Yeah.
So, is this completed? Data acquisition concept? Is this completed or not?
Yeah, we did.
Data cleansing, data scrubbing, data mapping,
That's true.
and aggregation. Up to here, we completed, right?
Yeah.
Okay then. So,
We did the joint. I think I spoke about the joints also.
sorry?
I think you mentioned about the joints also, but non-similar tables using joints.
Yeah, right. So, non-similar structure tables, we use joins to combine the data. If it is a similar structure tables, we use union to combine the data. So that is the data merging concept. Right? This is the unions and this is for joins, data merging, right? And data aggregation also we discussed. We have to discuss about this.
I want you to be as quiet as you can, okay? Hold on.
Okay, so we continue.
Bottom numbers, okay? Hold on.
Can we continue?
Yeah.
Come, now looking. Hold on.
Do we start?
I think
I want you to go into the room right now. Into the room.
Kitty, what is the problem?
Hello?
yeah, no problem. I'm waiting for you, Prasad.
Preeti?
Hello? Yeah?
Yeah, any problem?
Sorry, no.
Shall we start?
Yeah.
Okay. Okay. So we have to discuss from this slide, right?
Yeah. We finished this slide actually.
Okay. Are you able to hear my voice, both of you?
Yeah.
Okay, then, no problem. Okay. As we discussed yesterday, here we can store historical records and current data in the data warehouse, right? So when you store the historical records and current data in the data warehouse tables, we have to maintain some rules and regulations here. So here the rules for maintaining historical data is, see, first one, So source primary key should not be a primary key in the warehouse system. You already know about the primary key constraint in the database level. Am I right?
Right.
So what is the use of primary key?
Primary key helps you see unique records.
Unique. It accepts only unique value and not null value. It doesn't allow any duplicate or null values in the particular field, right?
Right.
Okay. So in this case, if you use the primary key as a constraint in particular column in the source table, so the same column we should not be used as a primary key in the data warehouse table itself, because here clearly understand this example. This 4 columns table is source table and the 8 or 9 columns table is the target table in the data warehouse. So here I am storing the customer information in the source table. Here customer ID, customer name, city and country. So customer ID is the unique identification column in the source table. So unique identification means it's a primary key constraint column. Okay. So by using this column only, we can easily or uniquely identify each and every person, each and every customer in particular table. Okay. So here definitely the source data may update number of times. For example, if the Suresh record or first record updates number of times, that means every update is captured by the data warehouse. That means the Suresh record from the source may be more than one record is stored in the data warehouse level. So that means one record is the latest record and remaining all are historical records, of course. But here in the source table, primary key column should not change. Once the primary key value is assigned to any person, it is constant. Right or not? So the primary key is constant always. You cannot change the primary key value. So we can change only non-key column values. Maybe we can change the name, maybe we can change the city, maybe we can change the country also. So whatever the update happened here in the source table, so the entire updated record is captured by the data warehouse and stored as a new record. So if the data warehouse stores it as a new record, for this particular new record, the customer ID value is same. That means it's a duplicate value. If customer ID as a primary key in the data warehouse level, then it doesn't allow any duplicate values and null values. Based on this concept, source primary key should not be a primary key in the warehouse system. Understand? Actually, in the RDBMS level, Relational Database Management System level, each and every record should maintain, each and every record should have to identify with any other primary key column, primary key value. So based on this, we have to introduce new column as a SID in the warehouse. So SID is a surrogate identification column in the data warehouse table. Surrogate identification column is used to uniquely identify the each and every historical record in the database table. So here SID is a primary key column. We can insert the sequence values in the SID column. So if the SID column is primary key, it doesn't allow any duplicate and null values. So then only by using this SID column, we can easily uniquely identify each and every history in the database table, right? For this purpose, we have to use SID column as a surrogate identification in the data warehouse. Next. So here in the data warehouse table, we are using to store complete historical and current records. So for each and every source single record, there is a number of records in the data warehouse table. So among these records, only one record is the latest record, and rest of these historical records. So how can you identify the which record is updated and which record is historical? So for this purpose, we have to introduce flag column additionally. So by using this flag column, we can easily identify the which is new record. That means which is updated record and which is historical record. Here, if current data is represented as new value, the historical is represented as a old value. Maybe sometimes in some scenarios, to current data represented as a 1 and historical data represented as a 0 also. 0 means old data, 1 means historical data, or else new old, whatever the format we are using. So the flag column mainly used to identify historical and current data in the data warehouse table. Next, so for each and every source record, so updates number of times separately. Maybe Suresh record updates 5 times in the source. Maybe Surya record updates 10 times in the source. Maybe Siva record has updates 100 times in the source. So we have to identify how many times updated a source each and every record. So for this purpose, the version column is used to identify the updates of number of updates of each and every source record separately. For example, Suresh record updates 5 times. That means the latest record's version value is 5. So based on the latest record's version value, so we can easily identify the number of updates of the Suresh record in the source table. For example, Surya record updates maybe 10 times in the source table. Then the latest record of the Surya's version column value is 10. Based on that version column value of Suresh record only, we can easily identify number of updates of the Suresh in the source table. So likewise, each and every record from the source table. Okay. And so sometimes we have to identify the duration of the each and every update from the source. For this purpose, we used to take start date and end date. So for example, I'm an employee. I joined one company 3 months, today. So today means my record is inserted as in the employee table in source database. So same record is reflected to data warehouse as well. So after 3 months, I moved to USA from India. Okay. So the country value is changed in the source database. So here update is happened, then the update is captured by the data warehouse system and inserted as a new record in the data warehouse table with country column value is US. So here, so start date of the US is system date always. Start date of the India is also system date always. So here start date is always system date. So system date means today's date, right?
Yeah.
But end date of the each and every historical record is start date of the updated record always. For example, end date of the Indian location, start date of the US location is same. Understand what I'm saying?
Yes.
So here. So for this purpose, actually, we are using all these different types of rules here when you store the historical records in the data warehouse. So based on these all additional columns only, we can easily analyze the existing information completely when you compare historical and current information. Okay?
Prasad, I have a question.
Yeah, ask me.
So, for the version, when suppose Suresh name changes to, SUREESH, so that'll be version 2 in the database, right?
Yeah, right.
So, my question is that how do we get to know that from what to what did it change? By version, does it mean that it will show us all the versions, like kind of version control?
Yes, sure, definitely. For example, here version increments the value for each and every source record based on the source primary key value. Okay. So because source primary key should not change, always it is constant. That means customer ID always constant for Suresh person.
Right.
So the remaining columns, maybe customer name or city or country may change at any time. Based on the changes, each and every change is captured by data warehouse. So and it inserts as a new record. If it is inserted as a new record, the customer ID is same always.
Right. Got it.
Any of the other field will change. Okay. So based on the customer ID of source each and every record, we increment the version value separately for each and every source customer ID.
Right. Got it. Got it. So you are saying that there will be the customer ID will remain the same, and Suresh will have one more Suresh inside it, and there will be version 2.
Yeah, right.
There will be a next row, basically.
One more Suresh means the same person record,
Yeah.
but the updated information.
Right. Right.
Right.
Got it.
Yeah. Initial extraction and delta extraction. So first of all, we already discussed about the extraction. What is extraction? What is extraction? Anybody?
It's the first extraction that you do from.
I'm not asking you first extraction, second extraction. Just I'm asking you what is extraction. So ETL, what is ETL process? Extraction, transformation and loading. We already discussed yesterday. So extraction means
Retrieval of data.
yeah, right. So retrieval or collecting whatever. Okay. So here actually data warehouse captured the data from the source database, right? Each and every update. So is there any limit for updations? Maybe the database should limit updates only 10 times or update only 100 times or updates only 1000 times. Is there any limitation? No.
No.
So the source data may updates at any time number of times, right? So whatever. Actually, just clearly assume we have only one table in the source database and we have only one table in the data warehouse. So here, the data is moving from source database to data warehouse. So data warehouse always captures the data from the source. That is the point here. So what I'm saying is, actually initially I stored 4 records in the source table. So source database is updated. The data warehouse is ready to capture the updates from the source. So whatever the inserted records in the source 4 records, these every 4 records captured by the data warehouse system and store it in data warehouse table, right? This is the initial extraction. Whatever the records you initially inserted in the source table, the same records are inserted in the data warehouse table itself.
Right.
And the delta extraction means from second time onwards. From second time onwards means what type of data extracts by the data warehouse? Inserted records or updated records? Both.
Both.
Right? First I inserted 4 records only. After extracting the data warehouse, next day I used to insert one more record. So one more record means 5th record is inserted in the source table. Then the source table is updated. The particular update is captured by the data warehouse always, right? So the second day, that means it's a second extraction. And one more thing is already existing 4 records I want to update. So I already updated existing 4 records, of course. So updated records also captured by the data warehouse system, right? So that's why here initial extraction means only inserts or inserts. Whatever the inserted records in the source database, the same records inserts in the data warehouse itself. But coming to delta extraction, so it inserts or inserts and updates or updates both. So that means new record. If you insert new records in the source table, those new records also inserts in the data warehouse table. If you update the existing records, then also the data warehouse captures those updated records and insert as a new records. Understand?
Yeah.
So that's why initial extraction is the first time extraction. Delta extraction is the from second time onwards. From second, third, fourth, or 10, 100, whatever. Okay? Next. So slowly changing dimensions. Okay. So first of all, what is dimension table? Do you know about dimension table?
I read about this one.
No problem. See here, actually, terminology is the difference, but everything is same. So OLTP maintains transaction and master tables, whereas in data warehouse maintains dimension and fact tables. The terminology is different. Understand? So here, where you store complete historical and current information in the data warehouse level, and the dimension tables only. Okay. So here we have different types of dimension tables in the data warehouse based on the insert type of data, inserted type of data. So we can classify into 3 different types. So one is type 1 dimension, type 2 dimension, and type 3 dimension. So what is the use of type 1 dimension? Nothing. Just type 1 dimension is used to maintain the source master data as it is. So type 1 dimension is used to maintain the source master data as it is. That means here, clearly observe this example. So there is 3 columns table in the source, 3 columns table in the target. Is there any difference between these 2 tables? Same number of columns, same corresponding data types, and same constraints. Nothing different is there, right? The same structure. So what is the importance of the same structure? Just as it is, we can move the data from source to target. There is no any changes at all. So if you are trying to maintain some historical records also, is not possible here, because department number is a primary key in the source table. As same time, department number is the same primary key in the data warehouse table also. So it doesn't allow any duplicate values and null values. That's the reason why we cannot insert we cannot insert historical records and current records, because whatever the historical and current, the department number value should be same, because it is a primary key value. So once the primary key is assigned, it doesn't change. So only non-key columns will change from the table, right? So based on this concept, we have to migrate the data from source to target as it is. That's it. Am I right? So what is the use of this slowly changing dimension 1? We have 3 different types of products in real time, projects. So what are those? Migration projects, few development projects, and supporting or enhancement projects. Understand? So what is migration projects?
Data migration.
Version migration or database migration, whatever. Actually, data migration from one database to another database.
Right.
Or else older version to new version. These type of projects. Okay. So for example, if you are using mainframes, the output mainframe should be stored in the flat file. Flat file means notepads. So from notepads, we cannot generate the reports that's why we have to move the data from notepads to any other relational database management system. So for this purpose, we are using one migration project. So in this project, the data is migrating from flat files to, flat file is also one of the database. So from flat files to any relational database management system. Okay. So these type of projects we are using slowly changing dimension 1. SCD type 1 tables. Understand?
Yeah.
Right. And type 2 dimension. So actually type 2 dimension is mainly used for storing complete historical and current information. So whatever the rules we discussed a few minutes back, all the rules are applicable in this type 2 dimension only. So here in the type 2 dimension, we can maintain limited number of histories or unlimited number of histories. So whatever, based on the requirement. So for example, clearly observe this example. DPT number, DNAME and location, three columns table is the source table. So from this, we have to maintain complete historical and current data. If you want to maintain complete historical, you have to follow the rules and regulations. Here, no need to maintain any primary key as a source primary key as a target primary key, and we have to use SID column to uniquely identify each and every historical record in the data warehouse table. We have to maintain this column as a primary key, and flag column to identify the new or old record. Version column is to identify number of updates from each and every source record, and start date and end date columns for each and every update duration, right? So all these are we have to maintain here in the slowly changing dimension type 2 only. So here, if we consider the fixed number of histories, then each and every source record, we are using 10 histories. So 10 histories means if the source record updates more than 10 times, that means oldest record delete from the data warehouse, latest records inserts in the data warehouse. That is the concept here. So always we are maintaining only 10 records. For example, so more than 10 records means if the 11th record is coming from the source, the first record will delete from the data warehouse. Once first record is deleted, there is 9 records, and latest record, if you store this, total 10 records. For example, if the 12th record is coming from the source database, second record is deleted. Second means the oldest second record. So the latest record is joined in the table. So likewise, so we are storing for each and every source record, we are maintaining 10 updated values in the data warehouse. That is the fixed number. Okay. So if you want to go for unlimited number of histories, we can store like this, whatever the number of updated records in the source table. So each and every update is stored in the database. Okay. Next, type 3 dimension. So in this type 3 dimension, just we used current record and just recent previous history. Recent history only, not all the records. Just one is current record and one is recent historical record. We have to maintain only 2 records. Okay. So for these 2 records, we don't want to maintain separately each and every record. So here some memory issues are there. For example, in our source table, there is 100 number of columns. One is primary key column and other 99 is non-key columns. Maybe among these 99 columns, any of the single column changed in the source table, the entire record is captured by the data warehouse. Entire record means rest of 99 columns are same values, right? 99 column values are same. Only one field is updated in the source. That means here we are storing the duplicate values in the data warehouse level. The memory is always this, but no problem. So that is the reason why here in the SCD dimension 3, we are using for each and every non-key column, two columns in that data warehouse table. See here. So DEPT number, DNAME and location, 3 columns from source table. DEPT number primary key, it doesn't change in the source table. So for this, DEPT number is same as a primary key in the data warehouse also. For source non-key columns, for DNAME, new DNAME, old DNAME, 2 columns in the table, data warehouse level. So for location also, new location, old location. Here, old DNAME and old location contains previous historical information. New DNAME and new location contains latest information. Yes. Understand?
Yeah.
Okay. And schema. So actually, schema arrangements. So we have 3 different types of schemas in the data warehouse. So one is star schema, second one snowflake star schema, and third one integrated schema. So first of all, what is schema? What is schema? Anybody know?
So in the dimension, schema is the way the data is extracted from.
Simply say the definition. Just I'm not asking you the extraction and the dimensions, facts, all these things. Just what is schema first? Nothing. Schema is collection of objects. That's it. Whatever the object, maybe tables, views, indexes, sequences, synonyms, functions, procedures, triggers, whatever. Schema is a collection of objects. For example, here it says star schema. 4 dimension tables, 1 fact table, total 5 tables. So collection of these 5 tables is called star schema. Just example, not these 5 tables, just I'm saying. Okay. So just collection of objects is called a schema, that's it. So actually, okay. So star schema, it looks like a star format. In this star schema, the table arrangement is 1 fact table and number of dimension tables. All these dimension tables communicate with this fact table with foreign key relationship. Okay. So here, in the dimension tables, we are storing complete historical and current information. What about fact table? What type of data is stored in the fact table? So in the dimension table, we are maintaining completely primary key values. In the fact table, we are maintaining completely foreign key values. From these foreign key to dimension table primary key, we are maintaining the relation. So here, are you getting my point?
Yeah.
So in the fact table, we have what? Matrix?
Sorry?
In the fact table, we store what? Matrix?
Yeah.
I mean, in the dimension table, you mentioned historical and current data. But
Yeah,
the
right,
fact table
exactly.
can
The
carry-
fact table maintains the numeric information, only numeric information. Other than the numeric, we doesn't store in fact tables. Maybe character data, date type of data, all these are information it doesn't allow. So fact table maintains only numeric information. So whatever the number of columns, every column is a numeric type. Okay, maybe identification columns or cost or sales price, whatever. So fact tables maintains fact column and non-fact column. So what is fact column and non-fact column? We'll discuss later. So actually clearly understand the dimension tables maintains complete historical and current information. Fact tables maintains only numeric information. Okay. So actually, for these two tables, data is coming from only source master tables, master table and transaction tables. So actually here, it's a dimensional modeling. We are using dimensional modeling in the data warehouse. We are using entity relationship model in the source database. Source means OLTP. So OLTP maintains the entity relation model. Data warehouse maintains the dimension model. In the entity relationship model, there is a relation between master table and transaction table. In the dimension model, there is a relation between dimension table and the factor table. Just the arrangements of tables and relations, foreign key relations, primary key constraints, all these are same. Whereas in OLTP or OLAP, both. Only the difference is terminology. Actually, here, so dimension table maintains the source master data. The dimension table means this is the dimension table. These dimension tables get the data from the source master data, master tables. Factor tables get the data from the source transaction tables. Understand? Okay. Snowflake star schema. So nothing. Extension here, one fact and these four tables. Up to this is a star schema. In addition to just master dimension tables, if you use the relation between dimension and master dimension, this is the Snowflake star schema. Just this is for only improving the performance of the data warehouse. So what is the use of master dimension table instead of what is the use of Snowflake star schema instead of the star schema? Actually here in the star schema, we are storing complete historical and current information in the dimension tables. So we discussed a few minutes back one example. For example, in the source table, there is 100 columns. Any of this 100 columns, just one column updates from the source, the entire record is stored in the data warehouse. That means only one column is the new value, rest of 99 columns are duplicate values, right? So here the memory is it accepts the more memory from it uses the more memory from the data warehouse level. Understand? So that means redundancy and consistency will occur from dimension tables and factor tables. If you write some queries from the factor tables to getting the data from the dimension tables. So here actually problem is we have to reduce the memory. Sorry, what I'm saying is we have to split these dimension tables into two different tables. One is dimension and another one is master dimension. We have to maintain complete foreign correlation between these two tables. The purpose is, for example, in the employees information, for example, employee column, employee number, employee name, designation, salary, commission, and department number. These are all different from each and every person. Maybe somebody is working in one department and somebody is working in another department. Everything is different for all these columns. Actually, we have three more columns: country column, nationality, and currency column for each and every person. So the employee belongs to country India. That means the country column for every employee is India always. And the nationality for every employee, whatever the religion, the nationality is always, everybody is Indian, right? Christian is also Indian, Hindu is also Indian, and Muslim is also Indian. Everybody is Indians. And currency of the Indian currency is also rupee for every candidate, every employee. That means we are identifying the unchanged data in the dimension table. If you identify any unchanged data in the dimension table or in the source master table, then we have to extract these three particular unchanged columns from the dimension, and we has to create another master dimension table and store it as a new record in the particular master dimension table. From this master dimension table, if you use any foreign correlation to dimension table, then all the records of the master dimension table is associated with dimension table records, right? So here we are reducing the allocation of memory. Are you getting my point?
Yeah.
Do you understand or not?
Yeah.
I got it.
If you have any doubt, please ask me. I will explain again. Yeah. So for this purpose, we are going to move the data to snowflake star schema. So already this is the drawback in the star schema. So in the dimension tables, it allocates more memory for each and every record to store, because here we are storing the complete duplicate information in the dimension tables. So complete duplicate information. So is there any way to reduce the duplicate information storage? No. There is any, maybe, do you know this particular column only updates in the source table? These are the different columns. These are not updated in the source table at any time. These are the unchanged columns. These are the changed columns. Do you identify this from the source database? We can't identify. Depends on the situation and depends on the business process, depends on the environment, everything. Whatever the reason happens in the database level, any data, any non-key column will update at any time. Any non-key column will update. So based on that, each and every needs to capture and store it as a new record in the data warehouse level. That is the importance here. In this case, we can't identify the unchanged columns from the source column. Maybe in some cases, if you can identify the unchanged columns in the source database, then we can create a snowflake star schema. In the snowflake star schema, just we create master dimension table. In this particular table, we store those unchanged columns. These records associated with this master dimension table, that means with the help of the fact table, fact column, we can retrieve the data from dimension table and from the master dimension tables as well. Okay. So just the importance of the snowflake star schema is to improve the performance of data warehouse. By reducing the allocated memory when you store the duplicate information in the data warehouse. That's it. Understand?
Yeah.
Yeah. And integrated star schema. In this, we maintain more than one fact table. So did you observe this? In the star schema and snowflake star schema, we have only one fact table.
Yeah.
Okay.
Mm-hmm.
In the integrated schema, we are maintaining more than one fact table. And each and every dimension table is communicated with all fact tables in the integrated schema. So this is the different schema in data warehouse. Actually, most of the data warehousing projects uses a star schema. That means 90% projects uses star schema. So only 5 to 10% projects uses snowflake star schema. 2 to 5% of projects uses integrated schema. Depends on the functionality and available information and business roles, all these things. Understand?
Yeah.
And coming to fact table. So fact table, what is the fact table and what type of information is stored in the fact table? What is the importance of the fact table? So fact maintains completely numeric information. Whatever the number of columns in the fact table, every column is a numeric column. Actually, these columns is classified as two types: fact columns and non-fact columns. So what is fact column? What is fact column?
Numeric.
Okay. No problem. So, with the help of a fact column, we can summarize the data. We can retrieve the summarized data. So, what is the importance of data warehouse? We already discussed yesterday. What is the W.H. Inman's definition? He provides 4 different characteristics. One of the characteristics is data aggregation. Techniques, transformation techniques. According to him, transformation techniques, data aggregation is the one of the transformation technique. So, based on the data aggregation technique, we can retrieve the summarized data from detailed data with the help of some aggregation functions, right?
Yeah.
So this concept is implemented in this fact table, is possible through the fact table, fact column only. So through the fact column only, we can retrieve the summarized data. Understand?
Yeah.
The fact columns are the key performance indicators in the fact table. Okay. So clearly observe this here. Summarized data. How can you get the summarized data? When you apply aggregation functions only, you can get the summarized data. So we can apply only summarized. We can apply only aggregation functions only on fact columns, not on non-fact columns. Okay. So first of all, difference between fact and non-fact is, the fact means where you can apply the business calculations. In which column you can apply the business calculations, that column is the fact column. In which column you can't apply the business calculations is, that particular column is a non-fact column. For example, we have 2 different columns in the fact table. One is product ID and another one is product cost. So product ID is a numeric, product cost is a numeric, both. As per the rule of fact table, we have to maintain the fact columns, right? So, we have to maintain numeric columns. So here, our 2 columns both are numeric, but one is fact column and another one is non-fact column. So product ID is the non-fact column. By this column, we can only identify the each and every product separately, uniquely. But by the help of product cost, we can get summarized data. We can apply the calculation. For example, one product cost is $10. What is the 10 products cost? That means 10 into 10, $100, right? Here we are applying the calculation, 10 multiplied with 10. Are you getting my point?
Yeah.
Are you able to understand or not?
Yeah.
I'm asking you, are you able to understand or not?
Yeah, I'm getting it.
So you're very late, giving very late.
No,
So
the
that's why I don't know.
connection is slow.
Okay, no problem. So in the fact, no problem. In the fact table, we are maintaining 2 different columns. One is fact column and one is the non-fact column. By using fact columns, we can apply the business calculations and we can apply the summarized, we can apply the aggregation functions to get the summarized data. Okay, so that is the importance of the fact table. So clearly, okay, so we don't want to discuss anything about the non-fact columns because there is no use of non-fact columns if you want to get summarized information from the database. So here we have a lot of importance on fact types, fact columns. These fact columns are again 3 different types based on the summarized information, based on the retrieving the summarized information through these fact columns. We can classify it into 3 different types. So one is additive fact, second one semi-additive fact, and third one non-additive fact. So what is additive fact first of all? In schema, we have one fact table and number of dimension tables. For example, we have 10 dimension tables. Okay. So one fact table and 10 dimension tables in the schema. So in this particular fact table, we have one fact column. So if it is a fact column, maybe it can be three different types: additive fact, semi-additive fact, and non-additive fact. If it is a additive fact, it returns a summarized data for all dimension tables. All means we have 10 dimension tables. So it returns the summarized data for all 10 dimension tables in the schema. If it returns the summarized data for all dimension tables, then only it is an additive fact. Understand?
Yeah.
Okay.
Semi-additive, but not all dimension tables. Just some dimension tables only. If it is a semi-additive fact column, it returns summarized data for some dimension tables only, and other dimension tables it returns detailed information. For example, we have 10 dimension tables. If it returns summarized data for 4 dimension tables, it returns detailed data for 6 dimension tables. Then it is a semi-additive fact. Understand?
Yeah.
Yeah.
So additive fact means it returns summarized data for all dimensions in the schema. Semi-additive means it returns all summarized data for some dimensions in tables in the schema. Non-additive means it returns only detailed data, not summarized data. Then it is a non-additive fact or non-fact, whatever it is, no problem. Non-additive and non-fact both are same. Understand?
Yeah.
Yeah.
Next, conformal dimension. Of course, the dimension tables also we have to put a normal dimension and conformal dimension. So we already discussed about the normal dimension table in every schema. The conformal dimension means the particular dimension table is used in more than one schema or more than one stayed with more than one fact table, or else it used in the more than one schema. That is the conformal dimension table. Understand? If one dimension table is used in more than one schema, or it's shared with more than one fact table. So that is the conformal dimension.
Okay.
Next, data marts. Okay, so what is data mart first of all? So subset of data warehouse is a data mart. Actually, set of data marts is a data warehouse. Set of data marts is a data warehouse. So here we already discussed about subject-oriented database in the definition. Subject-oriented database. What is subject-oriented database?
I didn't get you.
What is subject-oriented database? Anybody? Subject-oriented. We already discussed 4 different characteristics, right? Time-oriented database, non-volatile database, subject-oriented database, integrated database. So what is subject-oriented? We already discussed with example. For example, if you consider one product-based company, in this company, if you want to release the product from the data from the company, you have to maintain some different activities: raw material gathering and planning, design, development, manufacturing, marketing, sales, shipment, everything. All these are the business activities. Each business activity is called a data in the data warehouse level. Each business activity is a subject area. So based on the subject area, if you store complete historical and current information in the data warehouse level, that is called a subject-oriented data warehouse, right?
Yeah.
So here, each subject each subject is a data mart. That's it. That's nothing else. So each subject is called a data mart. So for example, if you want to maintain the complete data warehouse for any product-based company, so first of all, you have to maintain the first master table, OLTP database for the particular information for each and every data subject area. Each and every business activity is called a subject area. That means you have to maintain the information for each and every subject area in the OLTP level. This is considered as a data mart in the data warehouse level. That's the difference. Understand?
Okay.
So here, the maintaining data marts is two different ways: top to bottom approach and bottom to top approach. So top to bottom approach is defined by W.H. Inman. According to him, first of all, we have to maintain entire data warehouse schema. From this schema, we have to separate each and every data mart. For example, sales information goes to sales data mart, HR information is extracts to HR data mart, and finance information extracts to finance data mart from the entire data warehouse schema. In this, there is a problem with extracting from the data warehouse schema, because if you store the entire information in the data warehouse level, after that, if you want to extract the data mart based on the subject area, you have to check which record is from the which subject area. Based on that, we can extract the information into separate data mart. Otherwise, we can't do it. That's why here in the data warehouse schema, there is huge amount of data. Billions of records are available. From these all records, we have to fetch each and every record, and we have to find out which record is from which subject area. Based on that only, we have to extract this and store it as a separate data mart. It is very complicated process extracting the data from the data warehouse schema. So for this purpose, we are going for some other data mart. That is bottom to top level approach. So in the bottom to top level approach, we can create data marts directly from the OLTP database. That means from the sales subject area, we can move the entire information from the sales subject area to sales data mart in the data warehouse. We can move the entire information from the HR subject area from OLTP to data warehouse level HR data mart. So here, the data marts are independent. These are all not depending any data warehouse schema. Okay, so that is the way you have to understand here. So after creating the data marts in the data warehouse level, we can combine all these and store it as a single data warehouse schema in the data warehouse. Okay. So both are important for us actually. So this is for bottom level management people, and this is for top level management people. So top level management people means the CEOs, directors of the company. So that particular people can analyze the entire organization. So for these people, we have to maintain top to bottom approach. In this approach, directly we store the data in complete data warehouse schema. But here, in the bottom to top level approach, first we create the data marts, and then finally we integrate this into data warehouse schema. In this level, the middle level management people is very useful for this data mart. So that means our sales manager is responsible for only sales department. So sales department means it's a sales subject area in the OLTP. Sales subject area, that means it's a sales data mart in the data warehouse. So by using sales data mart, sales manager can analyze the sales department's progress. By using HR data mart, HR manager can analyze the HR department progress. Understand?
Mm-hmm.
Yeah.
Able to understand?
Yes.
Any doubts?
No.
Any doubts?
No.
No.
Okay. So, yeah, these are the difference between OLTP database and OLAP database. So these points already we discussed. So OLTP is just designed to support operational monitoring. Monitoring means this is best to run the business only. So we are just looking, observe the information from the OLTP database. But here in the data warehouse, it is designed to support a decision-making process. So after analyzation, we used to take decisions only. So it's a volatile information. Volatile database, it is a non-volatile database. Volatile means the changes reflects to other database. Non-volatile means the changes doesn't reflect to other database. It maintains only current information, while AP maintains complete historical and current both. So while TP gives complete detailed data, while AP gives a summarized data by using some aggregation functions. So while TP maintains entity relation modeling database, while AP maintains dimensional modeling. In the entity relation model, we are using master tables and transaction tables. In the dimension model, we are using dimension tables and fact tables. So while TP is best to run the business only, while AP is best to analyze the business. While TP is normalized database, while AP is denormalized database. Normalization means reducing the redundancy, reducing the allocation memory, wastage of memory, maintaining the consistency, integrity, all these things. These are the normalization concepts. So that's why while TP is not normalized, we can maintain completely primary key values, foreign key, relation between different tables. We can split the information into multiple tables, all these things. But here in the decision support system, it's a denormalized database. We can't, if you identify the unchanged information, then only we can split into two tables. Otherwise, we have to maintain the single table for any duplicate information. Okay. So the priority goes to DML operations in the OLTP database. Only retrieval operations in the OLAP database. Retrieval operations means we have to generate the reports by retrieving the information from the data warehouse. So only by data retrieval language we can retrieve the information. Retrieval language means select statement. So select statement gives the high priority in the data warehouse, and DML operations means insert, update, delete, because here we maintaining complete latest information. We can insert the latest record, new record. We can update the existing record. We can delete the unwanted record. So all these are performed in OLTP database. That's why the priority goes to DML operations in the OLTP. The priority goes to DRL operations in the OLAP. Okay.
Yeah.
It's OLTP or OPDB or entity relation management. It's a relation support system. So the concepts are completed. Please ask me if you have any doubts. So if you don't have any doubts, we can go to Informatica tool directly.
Yeah, I'm okay.
Do you have any doubts?
Okay. We can move.
Do you have this document? Did I send?
No, I don't think you sent this.
This one, today's and
Did I send
yesterday's.
this
We don't have yesterday's and today's.
I'm not getting you.
We don't have the PowerPoint.
What you say?
slides. We do not have the PowerPoint slides from yesterday's lecture and today's.
Yesterday?
Yesterday's PowerPoint and today's. We do not have them. Hello?
So this PowerPoint presentation you don't have, right?
No.
We do not,
I
I
need
do
to
not
send
have
it.
them.
Okay, I'll send this document to you right now. Please see. So Outlook, right?
Outlook.
And yeah. Okay, so please refer this document by tomorrow. If you have any doubts, we'll discuss tomorrow. And from tomorrow onwards, we'll start Informatica tool. Okay?
Okay.
Do I
I'll try
get
and
that
download.
software for Informatica also?
Yeah. You
I'll probably check
Preeti?
with the, yes, I'll probably have to check with the office.
Okay. Do you have Informatica installation in your system, Preeti?
No, I do not.
So what about practice?
That's right. So, do I have to check with the office and ask them if
You
they can
need to
give me
install
access?
the Informatica in your system.
Okay,
Okay?
right.
Okay. Yeah. Office means Vijay's Technologies or else
Vijay's Technologies.
which office?
Vijay's Technologies.
There is no any. Yeah. There is no any server access from the Vijay's Technologies. I only was to provide the service for you. Okay, I'll install the Informatica. I'll try to install the Informatica in your system. What is your configuration?
I'll send
Systems
you the
configuration.
configuration. I'll send you the details in a short while. And, we'll see if it is even possible.
Okay.
I will
Can
have a
use the
separate,
download link for you? Yeah, sure. Okay. I'll send you the download link for you. Just download by tomorrow. Most probably after the class, we'll try to install tomorrow.